In 1971, two physicists, Joseph Haffel and Richard Keating, take three of the most accurate clocks ever built. One clock stays on the ground. Haffel takes one and flies east around the world. Keating takes one and flies west. They begin at the same place and they all return to the same spot. And when they compare the clocks, none of them show the same time. The strange part, none of these clocks are broken. They all measured time perfectly. So then, what's wrong? Actually, nothing. The clocks didn't change, time did. But how can time change? This wasn't just a wild idea. Over a century ago, Albert Einstein realized something everyone else had missed. Time isn't universal. It doesn't flow at the same rate for everyone. Instead, it depends on how you move. The faster you move, the slower time passes for you. Not in your mind. Not because your clock is faulty, because that's how our universe works. This phenomenon has a name, time dilation. And surprisingly, it can be described by a single equation. Don't worry, it looks intimidating, but every part of it has a simple meaning. T, Earth equals T, ship, divided by the square root of 1 minus v squared over c squared. This equation tells us how much time passes on Earth compared to someone who's moving. T, Earth, is the time measured by someone at rest, someone standing on Earth. T, ship, is the time measured by the traveler, the person moving. V is the traveler's speed. And c is the speed of light. Now look at this part. The square root of 1 minus v squared over c squared. Physicists usually don't write it like this. Instead, they flip it and give it a name, the Lorentz factor, gamma. And the whole equation becomes simple. Earth equals gamma times t, ship. The easiest way to understand gamma, now think of it as a time stretch number. It tells you exactly how much slower time moves for the one in motion. Let's consider you're standing still. Your speed is 0. Gamma is exactly 1. 1 year for you is 1 year for everyone else. Time flows the same. Now, let's start moving. A commercial airplane flies at around 900 kilometers per hour. That's only about 0.00008% of the speed of light. Gamma isn't exactly 1. It's 1.0000000000003. So close to 1, that time barely notices. It really does slow down, but only by a few tenths of billions of a second over an entire flight. So tiny. You'd never notice it without an atomic clock. Now imagine a spaceship traveling at half the speed of light. Gamma becomes 1.15. 1 year on your ship becomes 1 year and nearly 2 more months on Earth. Now, push it to 99.5% of light speed. Gamma jumps to about 10. 1 year for you becomes 10 years on Earth. That's no longer a tiny effect. It's a completely different experience of time. At everyday speeds, the difference is far too small to notice. But as you approach the speed of light, it becomes impossible to ignore. So, let's turn this equation into a story. Imagine two identical twins. One stays on Earth, the other boards a spaceship, traveling at 99.5% of the speed of light. 10 years pass by the clock inside the ship. Then he turns around and comes home. The twins meet again. But something unbelievable has happened. The traveler has aged only 10 years. On Earth, more than 100 years have passed. His twin is now an old man. He is not. This famous thought experiment is called the twin paradox. Curious, what happens at 99.9% of the speed of light? I built a simulator for that. Change the speed, change the journey, watch time change. Link in the description. For decades, the twin paradox was only a thought experiment until 1971. Joseph Haffel and Richard Keating proved Einstein was right. And today, we don't just believe relativity, We depend on it. Every GPS satellite orbiting Earth carries an atomic clock. And because those satellites move so fast, their clocks tick slower than ours by about 7 microseconds every single day. Left uncorrected, that tiny error would push your location off further and further every day. Relativity isn't just a theory anymore, it's running silently inside your pocket. So, the next time someone tells you we all have the same 24 hours, just smile and tell them. Physics respectfully disagrees.